Hi, and welcome to the practical chapter on blurring and sharpening images in OpenCV. So now let's move on to our IPython notebook and let's start doing some blurring and sharpening. Okay, so now let's start the exercise on blurring and sharpening images. So let's open notebook number 7, titled here, and let's bring up our IPython notebook with our convolutions and blurring code, okay? And our sharpening code as well, all right? So firstly, what we're going to do is we're going to load an image in that we're going to operate on, and we're going to create a tree by tree kernel using np1s to create this kernel here, and it's divided by 9, so we actually keep it consistent 1/9 our values. All right, so that way we don't brighten the image unnecessarily. So what we do, we use our cv2.filter2d, that operation, to convolve our image with our kernel. Okay, we use a -1 here because the -1 specifies that we're keeping the same depth as our input image source. So basically this stands for destination depth, which is ddepth for short, which you'll see in the OpenCV documentation. And just use -1 by default if you want to keep it, okay? So now we're going to run this operation on with our tree by tree kernel. Then we're going to run the same operation with our 7x7 kernel, and you're going to observe the difference here with the different degrees of blurring and how different size kernels affect blurring. So let's check it out. So this is our input image here. It's nice and sharp, as you can see. This is it with our tree by tree blurring. So you can see it's definitely more blurred. It's a lot like smudgier, I would say, on the details here in this building. And now let's take a look at our 7x7 kernel. Wow. So this is significantly more blurred. It looks like someone with who needs glasses a lot, how I imagine they would see. I do need glasses, but basically I might see like this as opposed to this. So you can just see how larger kernels end up blurring the images a lot more. And that makes sense because what's happening with a larger kernel is that you're averaging the values across range, or like dimension, I should say, width to height, same thing. And that's why it's a lot more blurred. So now, these are some other commonly used methods of blurring: Gaussian, median, and bilateral blurring, which we're going to test out here. So let's take a look at each one. But let's start with this first. Let's start with the CV2 blur, and this is where we specify our input kernel here, tree by tree. And let's take a look and see how this looks. We're going to do the same here with Gaussian blur using a 7x7, and we're going to do a median blur here. So actually, for consistency's sake, let's just do tree for everything. And now let's take a look at how that looks. So we have our averaging here. So average, I should call, what do we call it exactly? All right, just a regular blur, I should say. And we have our Gaussian blur here. Now Gaussian blur, you can actually tell it's a bit better. It's blurred, but it's not significantly blurred. It actually looks a lot smoother. Then there's median blurring here, which I actually don't like. Just looks a bit almost like a painting, so it's actually not too bad. And this is our bilateral blurring here, which doesn't look like it blurred much at all. But if you look at the floor, actually, you can definitely see it did something here. It looks a bit artificial. It looks like it's just smoothing out the pixels over regions here. The regions that actually are kind of like one color. It looks a lot smoother here compared to the original. Actually, this isn't the original, but it's closest to the original. And we can see the sky looks roughly the same in this one, just a bit more blurred around the clouds. So that's a pretty cool observation. So now that you've observed those filters, you can see that bilateral is very effective in noise removal and keeping edges sharp. That's why areas that didn't have much details were very smooth, and areas that had detail like the building were actually very sharp. Okay, so I actually have a small little write-up in details about the bilateral filter if you want to experiment and use it more. However, now let's take a look at something else. And this wasn't included in the chapter before, but it's something I've added in because it's quite cool. It's called image denoising, and other means of reducing noise in images. Pretty much this comes from computational photography because a lot of noise filters do what I would say is unintelligent blurring, which, except for bilateral perhaps, which reduces detail to an extent that actually isn't nice to look at. So let's take a look at what these different noise reduction algorithms can do. So it takes a little while. So this here is our noise reduced image. And you can see it looks a bit artificial, I would say, but it's quite aesthetic, quite pleasing to the eye. And you can experiment with these as a homework lesson just to see how it looks. One is specifically works for grayscale, different types of images, grayscale again, so you can check it out and see. And what I'll do, I'll put some notes here at the bottom of this IPython notebook to indicate what these parameters do, okay? So these are the input arguments of the fast N1 means denoising colored function. So if you want, as an experiment for a homework lesson, you can toy with this function and see if you can come up with some nice parameter values that can produce nice looking images. Pretty sure it's going to be dependent upon the image, so you kind of want to experiment. These tools are not super intelligent to figure out exactly what you want, so you can actually mess with it and see if it helps some of your noisy or low quality images. So now let's take a look at sharpening, which we've seen in the presentation previously. Now let's remember this sharpening kernel we made. So now let's actually use it on our input image and take a look and see how it looks. Ta-da! Alright, so it's not that good, but it's exactly what we wanted. Sharpened images basically stress a lot on our lines, and this input image is perfect to illustrate that because there's a lot of lines, intricate lines in this building and on the floor here, or the road I should say. So you can actually see how much it emphasizes on these lines, which isn't really a good look unless you were going for this type of artistic style, which could look cool. However, it definitely looks over sharpened. So now that's it for sharpening, and that's it for this video. Alright, so just summarize what we've learned in that last video. We've learned how to use different blurring algorithms in OpenCV and how the different convolutional kernel sizes affect blurring. You've learned how sharpening is done in OpenCV and how to use the fast N1 means denoising colored function in OpenCV. Thank you. Up next, we take a look at thresholding, binarization, and adaptive thresholding. Thank you.